Hey, I'm Kristaps. Today I'm gonna tell you a bit about iOS security and reverse engineering iOS applications. I'll start with me. So I'm a lead security and test automation engineer at Test the Lab, and I'm working with automation projects, as it states. I'm working with security projects as well, like penetration tests, security audits, and that kind of things. I'm more involved in web and Android projects, but for the past recent months, it's come to iOS as well. So it's pretty exciting. It's pretty exciting for me as well. Today, as the time is quite limited for me, I'm gonna try to go over the basic concepts of iOS application security and ways how you can take a deeper look at it. And I'm gonna also try to demo you a quick example how you can peek deeper into your iOS application. Yes. I think I needed, I forgot one thing. I needed to enable screen recording for this presentation. Sorry about that. Just a second. So, QuickTime. And new screen recording. Okay, I hope that this will not eat my all memory. Okay. So, let's continue. Okay. So, before I continue, how many of you are Apple developers here? Quite a lot. Okay. And how many of you have ever done app reverse engineering? Maybe your own app. Okay. Fewer hands. Okay, but still a couple of people here. Okay, great. So software reverse engineering, like all the projects, like all the products. For any kind of type, they can be copied, right? A recipe of Coca-Cola is highly confidential, right? But you can actually take and analyze it and its taste and its color and that kind of things, and then you can actually understand what's in it, what it's made of, and that kind of things. Similar is with applications. Actually, you can even if you don't have the access of the source code, you can actually analyze the application, how it behaves, what functions, how it functions, what views it has, and that kind of things, and then you can get a better knowledge of it, right? This is how application reverse engineering works. So you try to analyze the application from all the ways where you can access it. Reverse engineering refers to process of deducing the implementation and design details of a program or system by analyzing the functions, the structures, behaviors, as I said, all the things that you can get access to, right? Application reverse engineering is actually a kind of a security threat to applications like instant messengers like Skype and WhatsApp, banking and payment solutions, as the data, the core data that they transfer, that they hold, like customer information, they are super important. So you want to make sure that they are secured when they are stored on your device, when they're sent over the network, and all the way. And how you can improve the security of your applications. Of course, you can use different kinds of methods, and Apple has provided built-in solutions that you're not even aware of. But this is a combination of anti-debugging, data encryption, code obfuscation, and a combination of all these things make it quite harder for example, for me, to break the application, to reverse engineer the application, and to get a deeper knowledge inside the application. So the reality is quite shocking. It's quite shocking for me as well, as I read some articles that there are quite more tools and techniques that you can use to break the application than those which help you to improve the application security. And if you take a general view from side on the application, on a given application, it might look like a big castle with the high walls and unbreakable. But if you take a step further and if you peek behind those walls, actually the structure of the application can be quite simple and can be revealed. So how this can be done? Yeah, what can you see actually? If I would say that you can see all the Objective-C interfaces, properties, exported functions, and global variables, some of the logics as well, would you believe? So there are techniques that actually can allow you to do this. There are tools, lots of tools actually that I found and that I've tried actually, a lot of tools that can help you through this process to take a deeper look at the applications. There are four main categories of these tools: the monitors, disassemblers, debuggers, and development kits. So I'm gonna go through quickly each of these to give you a look. So let's start with monitors. What can monitors do good for us? Monitors can help in sniffing, monitoring and recording target behaviors. There are tools like Reveal, Snoopit, and Introspide. These are quite popular, as I read. And for example, Sniffers. When using Sniffers, you can actually take a deeper look at the application's traffic that it's sending over the network. For example, this here on the screen is a man-in-the-middle scenario where actually we could set up an environment where you have a device and where you have a laptop, and if you could configure that the network traffic would go from your phone through your laptop and then to the internet, then probably you would be able to see some network data flowing through. It's not always true for secured network data, like when you use SSL and TLS connection, but for plain text HTTP traffic, it's very easily doable, and it can be done even without people's knowledge, right? I mean, without person's knowledge who is browsing, who is using the application, as an attacker can actually set up this environment transparently without someone knowing it. And of course, in the lab, this can be done even more easier. How do you prevent these kind of scenarios that someone can actually view your traffic? How you can protect your data in transit? Maybe you have heard about SSL pinning. How many of you have used SSL pinning? Right? Okay, few hands here. Okay, this is good. So for others, SSL pinning would add extra protection for your application in time when your application tries to connect to remote servers. When the application tries to send user data to the server and retrieve information from the server needs to be trusted. It's not always easy to trust the server. Just relying on the certificate that the server sends you you can actually then use this SSL pinning to store some kind of a checksum of the server that you trust, and then compare this checksum when you make these HTTP requests, right? So this is then considered to be more secured way. But the opposite side of it is that you need to keep track of that server certificate, and if it changes, you need to update your application and checksum accordingly, so that it's up to date and the connection still works, right? Okay. Then another tool, useful tool, Snoopit. Has someone heard about it? No? Okay, one person here. So it allows you to do runtime analysis actually, and how? It allows you to do runtime analysis by retrofitting existing apps with the bugging and runtime tracking capabilities. So key monitoring features for this tool is file system access, key chain access. You can peek into some kind of HTTP connections, debug outputs, and you can even trace some app internals, which might be useful when you investigate some application. And you can do some kind of manipulations as well as, for example, you can fake GPS location, which might be usable for applications which are restricted to run in specific regions. You can list available Objective-C classes, objects, and methods. I'm not really sure if this tool allows you to peek into actual methods logic, but method headers can for sure be extracted. I'm going to try to demo that in a bit. And yeah, you can also invoke arbitrary methods at runtime, which is kind of cool, and even bypass jailbreak detection mechanisms, which might be interesting. Okay. Then we have disassemblers. What are disassemblers? So they take binaries as an input, and they output assembly code after processing. So can someone here read assembly code? Can someone try to read? Okay, yeah, one guy. Nice. It's I never said that it's easy, but yeah, you can at least you can decompile the applications so far that you can get assembly code and take a look at those instructions there and try to filter out some logics. Yeah. So this is an example of IDA Pro disassembler. As you can see, there are a bunch of instructions there. But what is really interesting that you can even see some method calls here. So it's not really revealing a lot of information. Like the code is not so clever as you would decompile some Android application, right? But still, it's something, and you can maybe benefit of it in some situations, right? So in this moment, I would like to demo you how it's possible to extract something more, a bit more valuable from the application. So I'm gonna try to demo you how I can really extract the method headers from a compiled iOS application. So I have here jailbroken iPhone. So I'm gonna connect to this iPhone. Can somebody maybe tell me what is the root password if you just jailbreak your iPhone? Alpine, right? So it's Alpine, and yeah, I'm logged in as root in my iPhone. Then what I can do, I can find all the application bundles there, right?
It's very dark.
Oh, really? Okay. So Okay, let's try to somehow make it brighter. No. Preferences, appearance. Profiles, colors, okay. Background, white. Yep. No, I don't know.
Maybe try different background photos.
Yeah, I'm trying to set this up. I'm not sure how to do that actually. Select the text, background. You know, I'm gonna try to switch to different terminal. Maybe that will help. So this is a bit better, right? Maybe. So what we do here, we SSH to our jailbroken iPhone. Okay, I'm gonna I'm gonna search for all the application bundles installed on the iPhone. Okay, here we have some already, so let's wait a bit. So a bunch of applications there. So there are some user applications that I've installed there. There are also some built-in applications. And here, for this example, let's take a look at one of the built-in application, the App Store itself. So let's take a look at the App Store bundle. So where is it? Where is it? App Store here. So it resides here. Now I'm gonna try to extract the application bundle from the iPhone. So yeah. Sure. Thanks for noting.
A little bit more.
Yeah. Okay, maybe like this. I can stand like this. Okay. I can stand like this. Okay. I'm gonna copy over the application bundle to my Mac. Okay, you can already see the contents of this application bundle, some kind of JPEGs and other files there. So what we are really interested in, we are interested in this binary, which is stored inside here. App Store, this one, right? So, okay, yeah. So what we want to do with this binary, we want to do extract all the classes and all the method headers from this binary. So we use this kind of this tool which is called class dump. Class dump. Just a second. So. Okay. Class dump. Okay. So we have a file with methods. I'm gonna try to open it in editor so that you can see something. So where am I? Go. So the class file is here. Okay, now you see nothing. Okay, so who uses an editor with white background, right? So no one. So how can I? Sorry?
Just select all.
Oh yeah. No, that's not helping. It's gray. So let's use text or something, right? Text edit. No, actually, I'm gonna try to do it in less, like this. Great. Okay. So this is good. So this is what we can actually extract from the iOS application binary. So like data type definitions, some method names, and that kind of information. For example, I can search for database, for example. So I can find interfaces and that kind of information. Of course, it's not much, and it's not like you can see all the code and the logic of the application and all the methods, but still you can actually find here method names that you have actually written yourself. So if you're an Apple developer, you have compiled application, and if you will do a class dump on your application, you will actually be able to extract the method headers, and you'll be able to look at this data. That's what I wanted to demo, and yeah, let's continue with the rest of my presentation here. Okay. It's dark again. Can we get it brighter maybe somehow, or no? Yeah, okay. So moving up, next slides, the next category of tools, it's debuggers. So you all know debuggers, right? You can use your Xcode, for example, to set breakpoints of the application. Once the code gets there, it stops on the line, and you can then attach to it and take a deeper look. So the basic debugger for you as developers, it's Xcode, and if you have source code of any other application, it's Xcode. And then there is this other tool, LDB, which also can be handy. Then the fourth type of the tool is this kind of development kit. Of course, Xcode is as well as development kit for your App Store applications, but there is more. There is, for example, this iOS OpenDev toolkit, which can be integrated in your Xcode. And what for is it? It's for open source project development. It allows you to develop applications for jailbroken markets like Cydia, and yeah, it can be quite interesting to step out of App Store and to do some some other stuff which like your devices are capable of doing, but are restricted by Apple, right? Okay, then yeah, this is how iOS OpenDev looks when you have integrated this into your Xcode. You have extra options to look into, like to develop some applications which would access lower level of the device that you are deploying this application on, and interesting things. So yeah, these are the main things that I wanted to go through with you. Do you have any questions?